This video is going to have a look at esters for GCSE chemistry. Now, esters are sweet smelling molecules which are used as, they're used in perfumes to give them the sweet smell. They're also used in foods as well as flavourings. What we're going to focus on here is drawing esters and actually how do you form an ester from their initial reactants, what kind of conditions do you need for the reaction and what products would you get. And then we'll have a look at naming esters. Now what I've done first of all is I've drawn the functional group of an ester. So here in the centre we've got the carbon and two oxygens. So when you see this together in a molecule, this is when you've got yourself an ester. Now esters are formed from two key parts. They're from a carboxylic acid. They also they are reacted with alcohols, and then they'll form an ester as a product of this reaction. So our ester would be our main product here, and I'll put our ester in black here. I'm going to use colours in this video just to show you quite clearly where the different parts come from in the ester. It'll be important to have a look at that in a second. And then our other product here is water from the reaction. Now for this reaction, what you need is an acid catalyst in there. So I'm representing my acid here, so my concentrated acid catalyst with an H+. So that's our concentrated acid catalyst. So that could be something like phosphoric acid, or could be sulfuric acid for this reaction. The other thing that you'll need to do here is you'll need to heat this reaction as well. So you need to warm the reaction. You'll end up getting an ester and water from this reaction. Now let's have a look at how you would draw different esters out. So we'll look at it as part of an equation to start with. So the first carboxylic acid I'll draw, I'm going to draw ethanoic acid, which you should know about from looking at the carboxylic acids work. I'll draw an alcohol, and I'll draw methanol as my alcohol. So this is methanol. Now the reason why I want to draw colours here is to show you exactly where all the key parts of the ester come from. So the first thing to note is for the carboxylic acid, this part here, the OH group, that's going to be lost as part of the water. So the first part of the ester is going to be made up of the carboxylic acid. So this is where the double bonded oxygen is going to come from in our carboxylic acid. This OH here has gone off to make water. And then what we've got left on the end here is the O here. This O is the O here from the alcohol. And the CH3 group is stuck on to this end of the molecule. The extra hydrogen that was lost here, this hydrogen, has gone on to make the water molecule here on the other side. So that's an equation for the reaction of an alcohol and a carboxylic acid to form an ester. Now what we need to do that now is have a look at how you would name an ester from this drawing here. Now there are two important parts to an ester. So the first part here from the alcohol in blue is the first part of the name on the ester. Now because this alcohol was methanol, so it's got one carbon in the group, it's a methyl ester. So this group here came from methanol, that's where methyl comes from the methanol. Now the other part came from ethanoic acid. So this bit's an ethanoic acid. So this part is an ethan for two carbons. Now the end of a name, the suffix, this end part of the name for an ester, is an O8. So methyl for CH3 here, ethan, O8 for that part of the ester. Let's have another look at a different reaction then. So we're going to have a look at another formation of an ester. So if we have a look at this one here, let's start off with a different carboxylic acid this time. Let's try propanoic acid this time. So we've got 3 carbons in our chain. We've got the COOH group here for the ester. So this is propanoic acid. And for our alcohol, we'll do a different alcohol again. So let's do ethanol for this reaction. So for ethanol, we've got 2 carbons in the chain with the hydroxy group here, so the hydroxyl group here on the end. So that's ethanol. And then our ester is going to form. Using the colours again, we can see where all the key parts come from in our ester. So the first part of our ester comes from our carboxylic acid. 1, 2, 3 carbons in the chain. This oxygen here remains, the double bonded oxygen. These hydrogens are all still here as well. This OH group is lost as part of water, so that part's eliminated as well. And then the rest of our ester, our side group on our ester, comes from the remaining part of the alcohol. And the remaining hydrogen here that's lost, this one here, is gone off to form the water molecule as well. So our ester, our name of our ester here, this is our side group here. So we've got our ethyl from the alcohol being ethanol. So ethyl. And then we've got 3 carbons in the rest of the chain. So it's propan for 3 carbons. And then the remaining part of the ester is an O8. So our ester is ethyl propan O8. So I hope that's been helpful. You should be able to do this for GCSE. You should be able to work out the name of the ester, the structure of the ester from drawing the initial diagrams. One more thing to look at would be what would the structural formula look like for each of these. So if we have a look at this one here, CH3COOH for ethanoic acid. Our methanol is CH3OH. And then our ester here, we'll use this diagram to draw it. So don't follow the name, follow the diagram for the displayed formula. This would give us CH3 for this group here, COO for these 3, and then CH3 for the rest of that ester. And then our other product is water on this reaction. For this one here, do the same thing again, CH3, CH2, COOH, plus our alcohol, CH3, CH2, OH, and then our ester, just follow the displayed formula, CH3 for the first 3 hydrogens, CH2, COO, CH2, and then CH3 at the end here. So that's the CH2 and CH3, and then H2O is water that's been lost after this reaction.